So lecture number 4, public key cryptography and message authentication. Okay, so this is the lecture. So here we are going to discuss 4 important concepts. So the first one is SHA functions, HMAC, RSA algorithm, Diffie-Hellman key exchange algorithm. So these are the 4 algorithms we are going to discuss. Okay. So these are the 4 algorithms we are going to discuss today. Okay. Now, let me go for secure hash algorithm, okay, or secure hash function. If you take secure hash function, what is the use of this? The use of this algorithm is to find the hash value, okay, to find the hash value of, okay, a given message. You can give any message into the hash function and it will create a hash value for this. So in SHA, there are so many different algorithms available. SHA0, SHA1, SHA2, okay, SHA2. There are so many different algorithms available in SHA. Okay, we can say it is a SHA family. Okay, it is a SHA family. So it was started in the year of 1993. Since 1993, there are so many, okay, different versions they are bringing. So what is the output? What is the difference means? The difference is the length of the hash value. Okay, the length of the hash value is going to be the different one. And also the input, how much of input it is going to take. Then how many rounds it is going to run. So these are all the differences. Okay, they are improving every day. They are doing some changes in their algorithms and they improve it. Okay, so these are the changes. Now you see SHA0, SHA1, SHA2 I'm taking. Only these 3 we are going to compare. If you see output size. So what is output? What is the length of the hash value? The length of the hash value is 160 bits, 160 bits, 256, 224, 512, 384. So if you see, it is keep on increasing. So they're increasing the length of the hash value. So this is the first difference. Then what is the block size? Block size means this is going to be the input. So the input also you can see 512, 512, 512, then it is going to 1024. So they are increasing the size. Okay, that means the input size, that means the block size they are increasing. Then number of rounds, how many number of rounds it is working. So some algorithms it goes up to 80 rounds, some algorithm it works up to 64 rounds. So there is some changes available in the number of rounds also. So what is the basic operations they are doing means there is no change in that. The basic operation is going to be exclusive OR operation. Okay, exclusive OR operation is going to be the maximum, okay, that they are doing. They are not doing any changes in this. Then maximum message size. What is the maximum length of your data? This is going to be block, each block. Okay, I'm having a message. I'm dividing my message into blocks. So each block should be 512 bits. But what will be the maximum size of the block? How much, okay, the message you can have? It is 2 to the power of 64. So it's quite a big number. So now they are increasing 2 to the power of 64 minus 1, 64. Now they're increasing 2 to the power of 128. So they are doing the changes in the input size. Okay, they are changing the block size. They are changing the maximum size, then the number of rounds, but the basic operation is going to be exclusive OR operation. There is no change in the exclusive OR operation. Now, there are a lot of algorithms available. We are not going to study about everything. Any one algorithm, if you study, almost the same thing will be available. Only the number of rounds is going to change. Only the input block is going to change, and the output block, the length of the output block will be changed. So we no need to study all the algorithms in the SHA family. So I'm going for only one. Okay, so what does that means? That is going to be SHA1 algorithm we are taking. In SHA1 algorithm, what are the steps available? Means totally there are 6 different steps available. Step number 1, the first step is going to be the padding step. Second step is dividing the pad. Third one, computing word 16 to word 79. Step number 4, declaring the initialization or the initial values for the 32-bit of words. Then a loop. So this loop is going to be the number of rounds. Okay, 80 rounds it is going to work. And finally, we are going to generate, okay, the hash value. So these are the steps. So padding, dividing, pad, computing word 16 to word 79, declaring initialize values for 32 bits, loop, and then final. So final is going to be generating the MAC value. Now, let me go to one by one. I'm going for the first step. So what is the first step means? You can take a data, any data you can take up to 2 to the power of 16. Okay, you can see the first table, you can understand now. So 2 to the power of 64, sorry, 2 to the power of 64 minus 1. You can take a data, that means a message like this, a very big message you can take. So I'm taking my message 2 to the power of 64 minus 1. This message you have to divide into blocks. We are going to divide into blocks. So how many blocks means you have to divide into 512 each. Okay, the block should be 512 bits. So 512 bits, 512 bits, 512 bits, you are going to divide into blocks. Suppose if your block is less than 512 bits, okay, you are dividing. I'm having a very big message. I'm dividing into blocks, 512, 512, 512, I'm dividing. So if the last block, if you see, it is less than 512. Okay, it is less than 512. Okay, for example, it is having only 20 bits of data. So what you have to do means you have to make this 20 bits of data into 512 bits of data. You have to convert. Okay, you have to convert the 20 bits of data. You have to convert into 512. So what is that process? What is the name of that process means? That is called padding. So what is padding? So I have only 20 bits of data. What I'm going to do, I'm going to add one bit, just one bit I'm going to add. Okay, that is one I'm going to add. Then I'm going to add zeros, continuously zeros I'm going to add. So why I'm going to add zeros means I want to make it 512. Then only the algorithm accepts. If it is less than 512, the algorithm is not going to accept it. So I just added one I'm going to add it here. Then I'm going to add the remaining 0, 0, 0, 0, zeros. Okay, all the zeros I added here. Then I'm going to add, okay, last 64 bits. I'm going to add something about this message. Okay, that means 20 bits. So this 20 bits, I'm going to write it here. So 20 bits is my data, original data. 1 bit, it is indicating, that means the padding starts. Okay, the padding starts. Then the last 64 bits, it is about how much of data available here, the original data. We have to write it in the last 64 bits. The remaining thing, we are going to fill it completely. We are going to fill it with zeros. In the last class, okay, I gave you the example how to solve it. So how many zeros you will fill here? Okay, how many zeros you can write it here means, so the total is going to be 512. Okay, the total is going to be the 512. Okay, you can take 512. Okay, so it is going to be 512 is going to be the total. So in this, you are going to reduce. You are going to reduce. You have 20 bits of data plus 1 bit. Okay, so plus 1 bit you are going to add it for that one. Then the last 64 bits you are going to use it to tell the length. What is the length of this message you are going to write? So this is going to be fixed. So what is the total? So this is equal to 512 minus, okay, 20 plus 1. Okay, so 20 plus 1, 21, 21 plus 64. So 21 plus 64, I'm using calculator. So it is 85. So I'm just writing 85. Then 512 minus 85. So 512 minus 81. So this is equal to 427. So 427 zeros we are going to pad. Zeros will be padded in this case. Please note down. Please note down or please write it somewhere. So 512, it is going to be the length of the block. Okay, the length of the block. You are having data, only 20 bits of data you are having. So you are going to pad, you are going to add some zeros. How many zeros we are going to add? So this is, we are calculating. So 1 bit is reserved for, okay, that means the beginning. It is the initial, that means the beginning of the pad. So you have to use 1. Then last 64 bits you cannot change. You cannot change. So I'm just adding everything. So this is going to be 85. So 512 minus 85 equal to 427. So 427 zeros will be added in this particular case. Okay, so this is padding stage. Then, so once padding is completed, you are having, okay, the data. That means 512 bit of block. Okay, this is going to be the block. Now, second stage. What is the second step? Means this block. That means, sorry, this particular 512 bit block. Okay, we have to divide this into, okay, words. We are going to divide this into words. So now, how I can divide the word? Okay, note down. So here I'm going to divide this into words. Okay, words. What is the length of a word? Means a word is going to be 32 bits of length. 32 bits of length is going to be a word. Okay, one word equal to one word. Okay, is equal to 32 bits of data. Okay, 32 bits. Now, how many words you will create now? We have totally 512. Okay, 512 bits of data you are having totally. So this 512, I'm going to divide this by 32. Okay, I'm going to divide this. Okay, this is one word. So 512 divided by, okay, I'm just dividing it by 32. If I divide this by 32, this is equal to 16. So 16 words you are going to get. 16 words you are going to get. Now you can see the diagram here. This is going to be your block 512. So this block I'm going to divide into words 1, 2, 3, 4. So how many words we are going to divide? This means we are going to divide this into 16 words we are going to divide. Okay, actually this is your message. Actually this is the total message. Block 1, block 2, block 3, block 4. So each block is 512. This is 512. Okay, not this. This is complete. You are having many 512s. Okay, you take one 512 block. So this one 512 block I'm dividing. Okay, I'm dividing this 512 block into words. So 16 words I'm dividing. So these 16 words I'm going to write like this. How to write means W0, that is word 1. Okay, word 2. Then W1, W2, W3 like this I'm going to write. So word 0 means that is going to be the first. Then word, then 2. Okay, so I'm going to write like this. So finally it is going to reach W15. So 0 to 15 words will be available. So this is step number 2. Okay, this is step number 2. Okay, you can divide. You how to divide your 512 block of data into words. So this is your complete message. So in your complete message, you will be having lot of blocks. We have done padding in the last block. In the last block only, usually padding will be done. Then we are dividing each block into words. So the length of each word is 16 bits. Okay, so this is step number 2. Now, let me go to step number 3. Step number 3 is, okay, now you can see already we are having the words from W0 to W15. We have 15 words, sorry, 16 words. Okay, we have W0 to W15. Okay, that means totally we are having 16 words we are having. Now, I'm going to calculate, I'm going to extend, I'm going to find. So what I'm going to calculate means I'm going to compute, okay, from word 16 to word 79, I'm going to compute. So that means I'm going to calculate, I'm going to generate the words. Okay, so you just think. If you just think, okay, you no need to study this. See, 512. So 512, this is going to be the block. 512 bits, this is going to be one block. So this block, we already divided this into 16 words. Now what I'm going to do, from these 16 words, I'm going to generate, I'm going to calculate, I'm going to find the remaining words. That means I want to make this completely as 80 words I want to complete. I want to make. So what is the formula for this? There is some computation, some formula is available for this. Okay, see, compute word 16 to word 79, extend 16 words into 80 words. So this 16 words I'm going to extend, I'm going to change it as 80 words I'm going to change. Okay, so what is the formula? So there is a formula available for this. Okay, the formula is very simple. So this formula you have to memorize. Okay, this is the loop. So what is that means? I'm going to create a for loop for I equal to, I'm creating a for loop, I is equal to, I'm going to start from, already we are having 0 to 15, I'm going to start from 16. For I equal to, okay, 16, I'm going to start from 16 to 79. Okay, from 16 to, 79. 79 means 80, 79. So from 79, I'm going to generate. Okay, now inside the loop, I'm writing inside the loop. So what is inside the loop? So word of, I'm writing W of, word of I. I'm calculating word of I. So word of I means word of 16, word of 17, word of 18, word of 19, word of 20, 21, 22. It is going up to 79. The loop is going to run. Okay, the loop is going to run. Okay, for many times the loop is going to run. Starting from 16 to 79, the loop is going to run. So it is going to create W16, W17, W18, W19. It is going to generate. So what is the formula here? So the formula here is, okay, given here. This is the formula. This is the formula. Okay, what is the formula here? W, okay, of, they are using J, I use I. Okay, no problem. Okay, I write it here. I make it very simple here. You can see here. So inside this, I'm going to write the formula. So W of I equal to W of, okay, W of I minus 3. Okay, I minus 3. Teacher, why I minus 3? We cannot, I don't have any answer for this because SHA algorithm is telling that. SHA1 algorithm, so they are following this. We cannot, okay, we cannot, what to say, we cannot give any explanation for this. So W of I minus 3. So what is I minus 3? I value is 16. 16 minus 3, okay, 16 minus 3 means 13. So they are taking 13 here. Word 13 they are taking here. They are going to apply the exclusive OR operation. Apply the exclusive OR operation with W of J, sorry, W of I means 16 minus 8. So minus 8 means, so 16 minus 8. Okay, 16 minus 8 means 8. So here 16 minus 3. So 15 and 8, they are going to do exclusive OR operation. Okay, they are doing exclusive OR operation. Then whatever the output comes, whatever the output comes, again they are going to do the exclusive OR operation with W of I minus 14. Okay, I minus 14. Then whatever the output comes, they are going to do the exclusive OR operation with W of I minus, okay, with the W of I minus 16. So these numbers you have to keep it in your mind: 3, 8, 14, 16. Okay, so I minus 16. So what we understand means they take 4 words. Okay, I minus 3, I minus 8, I minus 14, I minus 16. They are taking these 4 words and they are doing, okay, exclusive OR operation. They are finding the current. Okay, that means the new one they are finding. So this will be repeated. This will be repeated from 16, 17, 18, 19, 20. So the value of I is going to change. Automatically, the number is going to change. So finally, from WI, that means W16 to W79, we are going to calculate. So this is going to be step number 3. So step number 3 is compute word 16 to word 79. Okay, this is going to be the computation. Then step number 3. Yeah, step number 3. Then
Or this is fixed, doctor?
pardon, repeat.
This is fixed.
Yeah, it's fixed. This algorithm is this. Okay, this algorithm is this. Okay, we cannot change this. This line is given by SHA1 algorithm. Okay, so we cannot ask why it is coming J. Okay, J minus 3, J minus 8. This is the formula. According to SHA1 algorithm, they follow this, okay, the technique. So 3, J minus 3, J minus 8, J minus 14, J minus 16. So now what we have done, I just go to the previous slide, you see. Okay, we take one block. We divided this one block into 16 words we divided. Then the 16 blocks now converted into 80 blocks. It is now up to 80, 0 to 79. Okay, the same thing. You see, this is the second block. Here already we have 16 blocks, 16 words. The 16 words now we converted into 80. So the third block. So third block, we already have 16. Okay, that means 16 words we have. So the 16 words, now it is again converted. Okay, like this we are doing. So you see, we are having a very big, okay, bits of data we are having now. A huge bit of data. So here for B1, 80 words. B2, 80 words. B3, 80 words. B4, 80 words. So each word is 32 bits. Now, the next step is step number 4. So what is step number 4 means? Declaring some initial values. Now, these initial values also, okay, it is not given by me. It is given by the SHA1 algorithm. They are giving some initial values. What is that initial values means? You can say H0, H1, H2, H3, H4. Some values, okay, you don't need to memorize these values. Okay, no need to memorize these values. So H0, H1, H2, H3, H4. These are all the initial values given by this algorithm. Then constant values to be used in the loop. Okay, they're giving something called K0 to K99, K20 to 9. Okay, these values also given by the SHA1 algorithm. Now, so what is this means? See, H0, H1, H2, H3, H4. Okay, we can say A, B, C, D, E. This is a constant value. So these constant values are given by the SHA1 algorithm. Okay. Then they are having something called K0 to K19, K20 to K39, 40 to 49, 60 to 79. What is this? See, totally we have 80 words. Okay, 0 to 79, 80 words we are having. They are dividing this into 4 parts. Okay, they're dividing it into 4 parts. So K0 to K19, this is one part. Okay, then 20 to 39, this is another part. 40 to 49. Okay, every 20 they are dividing. For every 20, they are giving some values. What is this value? Okay, we can see it in the next slide. So now, step number 4, no need to confuse anything. Some values, okay, it is called the initial values. These values are given by the SHA1 algorithm. Okay, so what are the values? A, B, C, D, E. It is already given. Then K0 to K19. Okay, that means for first 20, there is some value they are giving. Then 20 to 39, 40 to 49, 60 to 79. So these values are constant and these values are fixed. We are not going to do anything. So that means totally you have 80 words in each block. We are dividing this into 4 groups, group 1, group 2, group 3, group 4. We are dividing this into 4 groups. So for the first group, there is some value. For the second group, there is some value. Third group, there is some value, constant. Fourth group, there is some constant value. So these are all completely fixed. So you and me cannot change it. Teacher, is it necessary to memorize all these things? No need. No need to memorize. In exam, they will not ask you to write it. Okay. So there is some value, constant value from K0 to K19, K20 to 39, 40 to 49. Okay. So these values are completely fixed. Okay. This is wrong actually. This is not 49. This is 59. Change it. 40 to 59. So 40 to 59, 60 to 79. So these values are completely fixed. Okay. Now, this is step number 4. I'm going for step number 5. Now, what is the step number 5? Means go to the first slide. You will understand now. In the first slide, what we told, this algorithm is going to run 80 rounds. It is going to run. Okay, it is going to run 80 rounds. Now you will see these 80 rounds here. So now I'm going for step number 4. So step number 4, it is going to have a loop. So this loop is going to run. How many times this loop is going to run means the loop is going to run 80 times the loop is going to run. Okay, so you can see for I equal to 0 to 79. Okay, I will simplify this here. Okay, let me simplify here. See, for I equal to, okay, for I equal to, we are going to start from 0 to 79. Okay, the loop is going to run 80 times the loop is going to run. This is going to be the loop. The loop is going to run 80 times the loop is going to run. Okay, so what is going on inside the loop? What is going on inside the loop? Okay, inside the loop, what it is going on means, now you can see already we saw some values A, B, C, D, E. So these values K0 to K19, okay, these values will be used inside the loop. Okay, it will be used inside the loop. Okay, what does that means? Now you can see here. So inside the loop, I'm having, okay, you see, this is the loop. Okay, this is the loop. Now, you see, what is available inside the loop means, inside the loop, we have something called F. There is a very important function is going on. Then we are having something called shifting. Only rotating, shifting is going on. This is the major. Now you can see here, temp equal to, so temporary value. I'm taking a temporary data, okay, temporary memory, temporary variable, okay, temporary equal to A left rotate 5. Okay, now what is this A? We already discussed what is A in the previous slide. Okay, so what is A means? So A is going to be some value. This is going to be A. Okay, so I take A, I'm going to rotate. How much rotate? I'm going to rotate 5 bits left. I'm going to rotate. Okay, no need to calculate all these things. So 5 bits, okay, it will be shifted. Okay, it will be shifted towards the left. Okay, 5 bits. This is I'm going to take, that is going to be 1. Then next one is going to be, I'm having a function called F. F is a function. F is nothing. It is going to be exclusive OR operation. So inside the F function, I'm going to send B, C, D. I'm going to send. Then plus I'm taking E. So E is also going to be available. Okay, E is also available with us. I'm taking E. So let me take E. Then plus I'm taking K. So K, you see, K is also already available from, okay, from the first round to 19th round. This is the K value. Okay, from 0 to 19. Okay, 0, I equal to 0, I equal to 1, I equal to 2, I equal to 3, up to I equal to 19. This value, the first value will be used. Then I value is changing. If I value is 20, 20, 21, 22, 23, 24, up to 39, this value will be used. Then 40, 41, 42, 40, up to 59, this value will be used. So every 20 iteration, the value of K will be changed. The value of K will be changed. Now you can see, I just take K. Then I'm taking word 1. Okay, word of I means 1. First word I'm taking. Then second word I will take. Third word, fourth word, fifth word, sixth word. We have, okay, totally 80 words available. All the 80 words will be taken in 80 rounds. So I just make it in a very simple way. You see, temporary. I'm going for A. Okay, I'm taking A. I write it in capital letter. A, already we know what is the value of A. It is given in the previous slide. Okay, the value of A is given. So I'm taking A. Where is it? Yeah, I'm taking A. So A, I'm going to rotate. So what I do, I write like this, R. R means rotate. Teacher, can I write like this? Yes, no problem. I'm going to rotate. So how much I'm going to rotate? I'm going to rotate 5 bits. I'm going to rotate. Okay. With this, I'm going to add. I'm going to send it into the F function. So what I'm going to send means B, C, D. So B, C, D. So all what is the value of B, C, D? It is given in the previous slide. No need to memorize it. Okay. The next one, I'm going to add it with E. Okay, add it with E. E also given. Then this is going to be K. Okay, this is going to be K. K is the key. For every 20 rounds, the K value will change. So this K will be used from 0 to, okay, so this K will be used from 0 to 19. This K will be used. If it is 20th iteration, the other key. Then 20, 21, 22, okay, up to 39. For 40, another key. Then plus, I'm going to take my key, my word. So word of I, I'm going to take. So word of I, I'm going to use it. So I means word 1, word 2, word 3, like this. So this is the formula, okay? Formula, we cannot do anything. We cannot change it, okay? So you have to take this as a formula inside the loop. Then after that, I'm going to change the value. So I'm going to make D equal to E. Okay, so whatever available in D, I'm going to move it to E. Okay, then whatever available in C, I'm going to replace with, okay, I'm just changing the values. Then, so C is equal to, okay, I'm going to rotate. So I'm going to rotate, okay, rotate B. So how many bits means I'm going to rotate for 30 bits, I'm left rotate. So I'm going to save it in C. Then B, whatever available in A, I'm going to move it to B. And whatever available in T. So T means temp. Temp means, okay, this is T. So I'm going to move it to A. So this is going to be the loop. So this will be continued 80 times, it will be continued. So this is going to be the formula for loop. Finished. Algorithm is over. So what we are doing, A, B, C, D, E, these values are fixed. Then key values are fixed. Key values for every 20 iterations, 20 loops, you are changing the key. There will be 4 different keys. So you are going to calculate the words from I, okay, that means from 0 to 79, you are going to calculate. So the loop is going to run like this. This is the concept. Now, you can see in the next slide. So what is going on inside the F function means there is nothing. Everything is going to be exclusive OR function only. It is going on. Then the next one is, okay, you can see the final. So what is the final means? You see here. The final is going to be after 80 rounds. Okay, you are going to run this for 80 rounds. After 80 rounds, what you are getting? You are getting new A, new B, new C, new D, new E. All the values will be changed now. The value of A, the value of B, the value of C, value of D, value of E, everything will be changed. Now, this we are going to take A, B, C, D, E. I'm going to add it with H0, H1, H2, H3. This H1, H2 also, it is already given. Okay, in step number 4, if you see the value of H1, H0, okay, H0, H1, H2, H3, H4, it is given. Now I'm going to add this with this, and finally whatever it is coming, that is going to be my hash value. So just think, I'm adding A, B, C, D, some values already given. I'm just sending it into the algorithm. We are doing it for 80 rounds. Finally, you are getting a different A, B, C, D, E. This A, B, C, D, you are going to add it with H0, H1, H2. Okay, finally, whatever it comes, that is going to be that 160 bits, that is going to be our hash value. So 6 different steps available. I just summarize, okay, one by one. First step is padding. Second step is convert each block into words. Then third step is convert it into 80 words. You will be having 16 words, convert into 80 words. Next step is loop. So here inside the loop only, we are going to use the values of A, B, C, D, E. Then inside the loop, we are going to use K1, K2, K3, K4. There will be 4 different keys. First 20 rounds, 1 key. Next 20 rounds, a different key. Next 20 rounds, another key. The last 20 rounds, another key. So 4 keys will be used. Then each, okay, it will run 60 rounds. Sorry, 80 rounds it will run. For every round, you are going to give, okay, your word, first word, second word, third word, fourth word, like this. So finally, you are going to get a new A, B, C, D, E. Now this A, B, C, D, E values, you are going to add it with your, okay, H0, H1, H2, H3. So this is going to be your new hash values. So whatever the output comes, okay, this is going to be H1, H2, H3, H4, H. Okay, you are going to add all these things together. You will get the hash values. Okay, so this is going to be your hash algorithm. SHA-1 algorithm is working like this. So no need to memorize the values of ABCD, the initial values. No need to memorize the values of K. Okay, so all these values you no need to memorize, but the loop, okay, what is available in the inside the loop, that formula you must know, and how to extend it from word, okay, 16 to 79. You are converting word 16 to 79. So what is the formula to convert this? Okay, so these two formulas are very, very important. Okay, so this is how the SHA-1 algorithm is working. So this is the first part of this particular lecture. Now, I'm going for the second part. The second part of this lecture, I'm going. So what is the second part of this lecture is, it is called HMAC. Okay, HMAC. Is it clear up to this? Any doubts you can ask me now. If you want to ask anything in SHA-1, I'm ready to answer. I'm not seeing the chat. I'm going for the next algorithm. The next algorithm is HMAC. So this is going to be very simple. What is HMAC? What is HMAC stands for? HMAC means hash, same hash, but here what you are doing means you are going to use some keys. Okay, some keys we are going to use. Okay, that means hash message authentication code. Okay, message authentication code. So here, how this HMAC is working? So this is a very simple algorithm. Okay, it's a very simple algorithm. I will directly go to the algorithm and I will explain. You can understand better. This is the algorithm. Okay, so this is the algorithm. So how this algorithm works? Okay, we can see. Now, what does this means? I'm having a message. Okay, so kindly note down. I'm having a message. This is the message. Now, this message, I want to send it to someone. So what you can do means, you can send it into the hash value. You can send it into the, you can send it into the hash function or hash algorithm. So your message, you can send it into the hash algorithm, and this algorithm will give you the hash value. Okay, it will give you the hash value. So you can say it is a hash value, or you can say it is a message digest. Okay, you can say it is a code, message authentication code. Okay, you can say different names available. Now you are going to send the message plus the hash value. You are going to send it to your destination. Okay, you will send these two things to the destination. Now, in the destination, they will use this hash value to verify whether the message is changed or not. Anybody changed the message? Okay, that is to check the integrity of the message. So they can use this hash value and they can check the integrity of the message. Okay, that is a concept. That is a general concept. Okay, so use of what is the use of SHA-1? The SHA-1 algorithm also the same use. Now what I'm going to do means, now instead of using hash, I'm going to use HMAC. I'm going to use HMAC. I'm going to use. So this HMAC, how the HMAC is working? In the previous concept, we used SHA-1. We used. Okay, in the previous concept we discussed in the same lecture today, we used SHA-1, but now I remove the SHA-1. I'm going for the HMAC. Okay, I'm using HMAC. So what is the use of HMAC? Means the HMAC will use a key. It will use a key. In SHA-1, Okay, I write the difference here. Please kindly note here. I'm taking message. I send it into SHA1 algorithm. I send it into the SHA1 algorithm, and finally I got the hash value. I got. This is general. This is what we studied in the last class. That means the last topic. But now what I'm going to do, we got a hash value. Now what I'm going to do, same message I'm going to take. I'm going to send it, into HMAC. I'm going to send it into HMAC, but in HMAC, you need the message plus you need a key. That should be a key. In SHA1, we are not using any key. Inside the algorithm, they are using key. We no need to bother about it. The user is not giving any key. The user is not giving any key there. The user is not giving any key. The algorithm is using inside, but here the user must give a key. Same like encryption. In encryption, you need a key, message plus key. The same concept here. To find the hash value, we are going to use a key here. Now, so come to the algorithm. This is my algorithm. I'm going to take my data. This is the data. So that means my data is going to be from here to here. This is my data. So my entire data is this Y0, Y1, Y2, Y3. I'm dividing this into blocks. So how many blocks and all, we no need to worry about this. This is going to be my data. Now, according to the MAC, that means HMAC, what we have to do means we have to add something called S1. I'm going to add a block inside or in front of my data. I'm going to add. So you can see what is that means. In the next slide, they're giving the explanation. So we are going to append the zeros to the left of the K, and we are going to create, nothing. We are just going to add something, append. Append means we are going to add something in front of our data. Now this S1, I'm going to add in front of my data. What is this S1? How to calculate this S1? So very simple. You can see I'm taking my key. This is a key. Key means they used to write K, but what is this K plus? Why it is called K plus? Suppose if your key is very small, if your key is very small, you have to add something, you have to add, pad. What is padding? We discussed in the previous concept. So you have to add, that means you have to pad it and you have to make it as a full size. So if your key is very less, padding will be done. So K plus means key padded. I will write it here. Now I just write it here. So what is K plus? I cannot write power, so I'm just writing plus here. So what is K plus means? So K plus is nothing. This is key padded. The key which is, if your key is very small, you have to do it. So this is key padded, K plus. Ordinary K means that is going to be your key, which is the correct size. The size of the key is correct. Now, I'm going to take K plus, that means my padded key, plus I'm going to take some value called iPad. What is iPad? Means the value of iPad is going to be fixed. So what is iPad means? iPad equal to 36, hexadecimal value. 36 hexadecimal, that means base 16. This is an hexadecimal value. One is 6. So 6 is going to be 0, 1. So this is. So the value of iPad is always fixed. It is not decimal. It is not decimal. Don't take it. Don't take 36. It's not 36. 36 of base 16. That is an hexadecimal number. So if I convert into binary, it will be 0, 0, 1, 1, 0, 1, 1, 0. So this is going to be 36. Now I take my padded key. I'm taking the iPad value. The iPad value is fixed in the HMAC algorithm. Then the two things I'm going to apply exclusive OR operation. I'm going to apply. I'm going to apply exclusive OR operation. Then whatever the output comes, that is going to be S1. So the S1, I'm going to add it, okay, before my data. So my data starts from here. This is my original data. My data starts from here. So in front of my message, okay, I'm going to add this. I'm going to append S1. I'm going to append. So what is S1? S1 is nothing, exclusive OR operation of iPad and K plus. So what is K plus? K plus is padded. Okay, K plus is padded key. Okay, K plus is padded key. Okay, now let me go to the next one. Okay, now whatever the output, okay, you are going to get some output. So this you are going to send it into the hash function. You are going to send it into the hash function. What hash function, teacher, I can use? You can use any hash function. SHA1, you can use it. MD5, you can use it. Any hash algorithm, you can use it here. Okay, so I took my data. With my data, I just added, I am appended something with my data that is called S1. I'm going to send it into a hash function. So for this hash function, what is the input I'm giving means my data plus I'm going to give a key. This is called IV. So what is IV means? IV is initialization vector. This is going to be the key. So this concept is not available in the previous one. So I'm going to use something called IV. So what is IV means? That is called initialization vector. So this initialization vector is nothing, that is going to be the initial value. So the initial value is going to be, okay, your key. So I'm giving my key plus I'm giving my data. It is calculating the hash value. Now the output is coming. Okay, output is coming. I can convert this into a formula. How can I convert this formula? See, I'm taking X. X is equal to, we are sending it into the hash. Okay, hash function. So what you are sending it, okay, that means S of I you are calculating. S of I we are calculating. Okay, and this we are going to concatenate. Concatenate means we are going to add it with your message. Okay, this is your original message. With your original message, SI is added. Okay, now I'm going to use a K. Okay, I'm writing here a K I'm using here. So that is the initial vector, or I'm going to use a K here. So with the help of K, I'm converting this into hash value. So whatever the output comes, I'm going to store it into X. So X is coming here. Then I'm going to do this is my first block. Then I'm going to do it for the second block. Now what is the second block? I'm going to add the data again. Now you can see, okay, actually not block. Okay, now again I'm taking the full data. I'm taking the full data. Okay, that means whatever the output comes, this is the data. Okay, whatever the output comes here, that is going to be the data. Now again I'm going to find something called S0. So what is S0 means? This time I'm going to use OPAD. OPAD. What is OPAD? OPAD equal to 5C. Okay, OPAD equal to 5C. It is already fixed. 5C hexadecimal number. Okay, OPAD equal to 5C. It is an hexadecimal number. Okay, hexadecimal number if you convert, so this will be 1010. This is 5. So C is equal to 1100. So this is 5C. So I'm taking 5C plus K plus, that is the padded key. These two things I'm going to, okay, I'm going to apply exclusive OR operation. This is going to be my S0. Whatever the output got from here, okay, whatever the output I got, this is going to be my message. Again, I'm going to send it into the hash function. The same key I'm going to use. Finally, whatever you are getting, that is going to be your HMAC value. So this algorithm is going to run only 2 rounds. It is going to run only 2 rounds. So in the first round, with your message, you are going to add something called S1 or SI. In the second round, you are going to add something called S0. Okay, but you are going to use a key here and you are going to use the same key here. Finally, whatever the output comes, that is going to be your HMAC value. Teacher, I didn't understand properly. Nothing. Very simple. Make it very simple. So I just take a Word document. Okay, so in the Word document, I just make it in a very simple way. You can find it here. So how to do it? See, this is your message. Okay, yum. So with your message, you are going to add something called SI. You are going to add something called SI with your message. So what is SI? SI is equal to, okay, SI is nothing. SI is nothing. Okay, this is equal to, so two things you are going to apply exclusive OR operation. Okay, so two things you are going to apply exclusive OR operation. What is that? Your K plus. K plus means this is called, okay, K plus means this is called padded key. Padded key means if your size of the key is less than the mentioned, you have to do padding. If your key is enough size, if it is having enough bits, means you no need to do any padding. So K plus, I'm going to exclusive OR operation with, first time I'm going to do it with iPad. Okay, I'm going to do okay with exclusive OR with iPad. So what is the value of iPad? Means the value of iPad is 36. Okay, not 36, it is 36 hexadecimal value. So you can convert this into binary. So this is going to be 0, 1, 1. Okay, 0, 1, 1, 0. So this is going to be your iPad value. So with the iPad value, you are take exclusive OR with your K plus. So whatever the output comes SI, so you are going to use the SI plus M. Okay, now what I'm going to do, I'm going to send this into a hash function. I'm going to take hash function. Okay, so into the hash function, I'm going to send, okay, the SI, I'm going to send plus the message. This is the original message I'm going to send. But here we are going to use something called a key. So this key I'm going to use. So key, I'm going to make it as a, where is that? Yeah, I just make this into subscript. Now you will understand. So I'm taking key. So this is, I'm taking a hash value. In the hash value, I'm sending the message plus SI. Okay, and I'm going to use a key. So whatever the output comes, so the output, this is equal to, let it be T, temporary. Okay, T. Now, the next step, what I'm doing, so the T is going to be the input. Okay, T is going to be the input now. So I'm going to take T. So plus, so with the T, I'm going to add S0, I'm going to add. Okay, S0, I'm going to add. Now, what is S0? The same formula. S0 is equal to, okay, S0 is equal to, S0 equal to K plus. That means your key, which is padded. So with this, I'm going to do exclusive OR operation with, now I'm going to use OPAD. Okay, I'm going to use OPAD. So what is the value of OPAD? The value of OPAD equal to 5C. 5C is the value of OPAD. It is an hexadecimal number, hexadecimal value. So if I convert into binary, 0101 1100. Okay, this is going to be the OPAD value. So I'm taking OPAD value. I'm going to, okay, make S0. So T plus S0. Now this T plus S0, I'm going to send it into a hash function. Okay, now I'm just copy this. Okay, so this is how you can easily remember the things. Now I'm going to send S0 plus T. So T is the output of the previous step. I'm taking, so the two things, I'm going to send it into my hash function. I'm using the key. Okay, this is going to be the IV initialization vector, or you can say key. So whatever I'm going to get, so this is going to be T1. So T1 is going to be your HMAC value. So this is what we are going to send it to the user. So this is going to be HMAC value. These are the steps. Okay, so this is the steps in this particular algorithm, HMAC value. Take a screenshot, take a photo, whatever it is. Okay, so this is the HMAC. So this is how the HMAC is working. Clear? The thing, I'm going to start from the beginning. Okay, I just repeat again. See, I take the algorithm so that you can understand easily. Okay, so this is the algorithm I'm taking. So okay, so listen. Now the same algorithm I'm writing here. Okay, to understand. Okay, I'm writing in a very simple way. The same algorithm. Okay, I'm going to repeat it here. Okay, to understand. Okay, so what is this? See. Now, listen carefully. I'm taking my message. Okay, I'm taking my message. I'm taking my message. So this is M. So M I'm taking. So you can see starting from Y0, Y1, Y2, Y3, Y up to Y of L1. This is going to be your message. Okay, I take this the message, the complete thing. From Y0, Y1, Y2, Y3, Y4 up to Y of L minus 1. This is my message. Now, so this message, I'm not going to send it directly. I'm not going to directly send it into hash. So what I'm going to do, I'm going to find something called SI. I'm going to find. I'm going to calculate something called SI. So this SI, I'm going to concatenate. I'm going to concatenate means I'm going to add, then I'm going to send it into hash. Okay. So what is SI? How to calculate this SI? That is going to be the next question. So the SI, how to calculate means SI is equal to, it is nothing. You have to take the iPad value. Okay, the value of iPad is fixed. What is the value of iPad? The value of iPad is 36. Okay, 36. It is an hexadecimal number. Okay, the value of iPad is 36. Now, so with this, I'm going to do exclusive OR. Okay, I'm going to do exclusive OR operation. So with my key, so what is my key? K. If your key is, okay, B bits, B bits. If your key is B bits, no problem. If your key is less than this B, okay, the B means it could be 64 or 128, whatever it is. If it is less than this B bits, you have to do padding. So I'm going to do padding. If I write K plus means it is padded. So padded means it is something added, some zeros, extra zeros added. Okay, so this is going to be the padded. Okay, now I just pad this and I'm going to do it. This is SI. I calculated SI. SI is equal to iPad value I'm taking. iPad value is 36. Okay, hexadecimal. So 3 means 0011. 6 means 0110. Okay, 36. I'm doing exclusive OR operation. I'm doing exclusive OR operations. Okay, like addition, subtraction. Okay, sorry, AND operation, OR operation. Okay, exclusive OR operation I'm applying with K plus. So K is your key, plus means padded. It is a padded key. Sometimes it will be padded, sometimes it may not be padded. Okay, depending upon the situation. So I got S1. Now what I'm going to do, I'm taking this S1, I'm going to concatenate, I'm going to add. Okay, I'm going to concatenate with message. Okay, concatenate means both together I just joined, not adding. It is not adding, it is concatenate, next to next. Okay, I'm concatenating SI and M. So this I'm going to send it into the hash function. Now I take the hash function. So inside the hash function, I'm going to send the SI. So SI we calculated. Okay, so SI we calculated. So we are going to concatenate. That means whatever concatenated into message. So this I'm going to send it into hash. Now for this, I'm going to use a key. I'm going to use a key. Okay, you see IV, initialization vector, it is going to be the key. So this key I'm going to use. So key, I'm going to make it like this. So this is going to be the key. Now, whatever comes output, I'm going to say this is equal to T. Whatever the output comes, Okay, I'm going to say T. So your T is going to be here. That is the T. So the T is going to be, okay, so this is the T. Okay, so T I'm getting here in this place. I'm getting the T here. So whatever the T it is, the value of T is coming here. I got the T here. Now the next step is, so T is going to be the input for the next. So T is going to be the input. So what I'm going to do now, I take T. Okay, so the next step is, let me take T. So T I'm taking. Okay, so T I'm taking. So with T, I'm adding S0 now. Okay, that means I'm going to concatenate. I'm going to concatenate S0. I'm going to concatenate. S0, I'm going to concatenate. Now the next question comes, what is S0? What is S0? We have to find what is S0. So S0 is nothing, same like this. Okay, you can see the same formula I'm going to copy here. So S0 is equal to, okay, S0 is equal to, it is not iPad now, this is going to be OPAD now. Okay, see, OPAD. Okay, I'm going to apply the exclusive OR operation with K plus, but the value of OPAD, what is the value of OPAD? 5C, it is fixed. It is fixed. I'm not changing. Okay, it is fixed. So value of iPad is 36. Value of OPAD is 5C. So now, so the 5C I'm applying. I got S0 now. So S0 I got now. Now what I'm going to do again? I'm going to send it. Okay, I can copy this line. Same thing now. It becomes easy. So now what I'm going to do? I'm going to find a new T1. I'm going to find. So T1 I'm going to find. So T1 is equal to, again same H hash value. Okay, hash algorithm K I'm going to use. Now I'm going to use S0 plus not message T. Okay, this T I'm going to use whatever I got it from the previous step. So now T1 is going to be your HMAC value. Okay, so T1 equal to HMAC. This is the HMAC value of the message. Yep. Okay, using the key. So what is the key we used? Key equal to K. So K is the key we used. So this is the concept of this. Okay, so this is how the HMAC is working. Okay, so no need to worry, everything is recorded. I will give the recording. You will understand. Okay, if you watch one more time. Okay, now let me go to the next. So the next concept is, you might have already studied in many places, RSA algorithm. Okay, RSA algorithm. Now I'm going to give an example. Okay, I'm going to give an example for this RSA algorithm. Okay, so then only you will understand. Okay, otherwise it will be difficult for you. So please, all of you, take a paper in exam. They may give some questions and they will ask you to solve. Okay, now the exams will be more like problem solving. Okay, like what to say, scenario questions. It is not going to be directly copy and paste. Yes. So I request everybody, so please take a piece of paper and keep it with you. Okay, I'm going for RSA algorithm. Okay, now what is a RSA algorithm, or how the RSA algorithm is working? Okay, we are going to discuss. We are going to discuss by using an example. You might have already studied this in some course. Okay, I'm not sure whether you have done any problem solving in that. So, but here I'm just going to solve a problem so that you can understand. Okay, RSA algorithm. Shall we start? Shall we start? Yes. Okay. Now, so what is RSA algorithm? Okay, the algorithm is explained in your slides. Okay, you can just go through the algorithm. Okay, the algorithm is available. But anyway, no problem. I'm going to solve the problem now. Okay, we are having some example also. So there is an example is also available, and they are giving, okay, example. There are some examples given, solved problem is available. So now, what is this means? I'm going to have a message, m equal to my message, let it be 7. This is my data. For this data, I want to send it to my friend or to a destination, but I'm going to use RSA algorithm. Okay, by using the RSA algorithm concept, I'm going to send this particular message. So RSA algorithm is a asymmetric algorithm. So asymmetric means there will be two keys used here, public key and private key. So two different keys will be used. Now, here there are three different steps available. The first step is key generation. So key generation is the first step. Second step is going to be the encryption. Then the third step is going to be the decryption. Okay, so these are the three different steps available in this algorithm. So we are going to see one by one. Okay, now I'm going for the encryption. So I'm going to take sender. Okay, please write it in the paper. Now I am the sender. So what I'm going to do means I'm going to generate a key. First step number one is key generation. So I have to generate a public key and a private key. Okay, I have to generate. Now, what is the algorithm says means the algorithm says the first step of this algorithm is you have to choose two numbers, okay, which is called P and Q. Okay, two numbers you have to select, and these two numbers should be a prime numbers. It should be a prime number, and these two numbers should be a different one. It should not be same. Okay, it should not be same. This is condition number one. I repeat, you have to choose two numbers. These two numbers should be prime. Okay, it should be prime numbers, and these two numbers should not match. Okay, it should not be equal. It should be different numbers. So this is going to be the first, the condition or the first step of this algorithm. Now, I'm going to choose two numbers. I'm going to choose. So let P equal to, I'm going to choose. So P equal to 11. I'm taking 11 is a prime number. You know what are the prime numbers? So 11 is a prime number. Then I'm going to choose Q, okay, because I have to choose both different. So Q I'm going to take as 3. So randomly you can choose any two numbers, okay, any two prime numbers which are not equal. So this is step number one. Okay, done. Step number two, please write it in a paper. Otherwise you will be confused. If it is possible, I have a calculator with you, okay, in the mobile. Now, second step is equal to number two. Second step, step number two, you have to find n equal to P into Q. So calculate n or compute n. So what is n means? N is equal to P into Q. So this is we are going to calculate. Okay, n equal to P into Q. So here in this case, n is equal to 11 into 3. Okay, 11 into 3. So that is equal to 33. So 33 is the value of n in this particular case. Okay, so this is going to be the second step. Okay, step number two. Then step number three. So what is the third step means? The third step is you have to calculate mu of n. Okay, mu of n. I don't know whether I can insert that symbol. Okay, let me find it. Okay, this is not exactly, but anyway. Okay, so next step is mu of n we have to calculate. Okay, mu of n we have to calculate. So what is mu of n is equal to, okay, the formula says P minus 1, P minus 1 into Q minus 1. Okay, so this is going to be the mu of 1. So in this case, okay, in our example, so what is this mu of n means? So I'm just copying this. So mu of n is equal to, okay, so P minus 1. So the value of P is 11. 11 minus 1 is equal to 10 into 10 into 10 multiply q of q minus 1. So value of q equal to 3. So 3 minus 1, it is equal to 2. So 10 into 2 equal to 20. So in this example, so mu of n equal to 20. So this is step number 3. Step number 3. Please note down. Then step number 4. What is the fourth step means? You have to find, okay, calculate the value of e. Okay, for find e, choose e. Okay, not calculate, choose e. So you have to choose e. Okay, there is something called e, you have to choose. Okay, you have to choose e. So what is e means? There is some formula for this. You have to follow this. That means GCD. GCD of, okay, GCD of mu of n. Okay, so mu of n. Okay, already we found mu of n, comma e, whatever the e you are going to choose. Okay, so for this, the GCD should be 1. The greatest common divisor of these two things, it should be 1. This is the condition. Okay, plus the value of e, it is always should be in the range of 1 to, okay, the value should be within the range of, okay, q of n, mu of n. So this is going to be the condition. So what is mu? Mu of n is 20. So from 1 to 20, you can choose anything as e. You can choose any value from 1 to 20. Okay, 20. Okay, because this mu of n we already found. We already calculated. So it is already calculated here 20. So it should be in the range of 1 to 20. But what is the condition? The GCD of mu of n, okay, and e, okay, it should be 1. The GCD should be 1. So how to calculate means I'm just taking you to a website, so where you can calculate the GCD. Okay, you can do it manually if you know, but if you are not able to do it, so you no need to worry. You can just go to the any website, okay, and you can calculate the GCD values. Okay, now I'm taking you here to the GCD. Okay, to calculate the GCD, there is a website available. Okay, so what is that? You can choose any values from, okay, you cannot take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, up to 20 you can take, not 20, up to 19 you can take. So in this range, you can choose anything as e. You can choose anything as e, but the GCD of mu of n and e should be 1. Okay, now for example, so the mu of n is 20. Okay, mu of n is 20. I'm going to take 2. I'm going to take. Okay, so 1 you cannot take. You can start from 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, up to 19 you can take. Your e value can be anything in this range. So now I'm going to take 20. So 2 I'm taking. I want to find what is the GCD for this. I'm going to calculate the GCD. The GCD is 2. Okay, I cannot choose 2 because GCD should be 1. I cannot choose 2. Then I'm going to try 3. I'm going to try 3. So I'm calculating the GCD. So if I calculate, okay, for 20, 3, if I calculate the GCD, so the GCD equal to 1. Okay, so 3 I can select. Then let me go for 4. I'm giving 4. Calculate. So the GCD is 4. So 4 we cannot use it. I'm going for 5. So 5, if you calculate the GCD, so the GCD of 20, 5 is 5. So 5 also you cannot choose. I'm going for 6. Calculate. Okay, this is GCD 2. So 6 also I cannot select. I cannot take as E. I'm going for 7. 7 is GCD. Okay, 1. I'm going to write. So 20, 7. Okay, the GCD value is 1. Then let me go for 8. Okay, I can calculate. GCD is 4. So let me go for 9. Okay, GCD is 1. So 20, 9. So 20, 9. Okay, it is going to be 1. GCD 1. Then 20, 10. GCD will be 10. Then 11. So I'm trying all different possibilities. I'm trying like this. So 20, 11 we can choose. 20, 11 if you choose, the GCD is 1. Then the next one is 20, 12. I'm going to take, so calculate the GCD. So this is 4. I cannot take 12. I'm going for 13. So I'm going to calculate. So 13 also you can choose. So 20, 13. Okay, the GCD value is 1. Then 14 I'm going. So for 14, the GCD value is 2. Then for 15, the GCD value is 5. For 16, so the GCD value is going to be 4. For 17, the GCD value is 1. So 20, 17, I can consider 17 also. I can choose it. Okay, I can choose as a E value, no problem. Then I'm going for 18. So 18, 20, the GCD is greatest common divisor is 2. So I can go for 19 now. 19 will be 1. So 20, 19. So you can choose anything from 3, 7, 9, 11, 13, 17, 19. So in this, okay, you can choose anything as your E value. Okay, so what I have done, I'm taking the GCD of, okay, your phi of n, that means 20, okay, start from 2, 3, 4, 5, I'm taking. So you are getting, what are the values we are getting means, we are getting 3, 7, 9, 11, 13, 17, 19. You can choose anything in this as E. So now I'm going to select my E value, let it be, I'm going for the smallest one for a safe side and for a comfortable calculation. I'm going to take E equal to 3. Okay, I'm going to choose. So choose E. You can choose the value of E so that what is the condition? The GCD, okay, the GCD of phi of n and E should be, okay, it should be 1 and E should be within in this particular range. It should be in the range of this. It should be greater than 1, less than phi of n. Okay, it should be in the value of 2, 3, 4, 5. Actually, it is not 1 to 20, it is 2 to 19. From 2 to 19, it should be in the range of 2 to 19. So I'm taking the minimum value 3 for safe computation. Okay, so 3 I'm going to choose. This is step number 4. So we calculated, that means we selected E. So E I'm going to choose, 3 is my E. Okay, next step. So what is the next step means? The next step of this algorithm is, okay, you can see the next step of this algorithm. So you can choose E, okay, E we selected. Then we are going to calculate D. Okay, we are going to calculate D. So how to calculate D? So what is the formula to calculate the D means? D, okay, you can calculate by using the formula, okay. So where is it? Yeah, I want to calculate D. So the formula is, okay, you can see D means D into E mod, okay, pi of n equal to 1. Okay, so this is going to be the formula. So now let me go here. Next step, step number 5. Okay, please copy it. So step number 5. What is step number 5 means? D into E. So we know what is the value of E, but we don't know the value of D. Okay, we don't know the value of D. So D into E, I write like this. Okay, make small letter D into E. Okay, so D into E. So DE mod pi of n. Okay, so this is going to be the pi of n. So I just copy the pi of n. Okay, so mod pi of n equal to, okay, equal to 1. Okay, equal to 1. This is the formula. So using this formula, so we have to find, okay, we have to calculate what is the value of D. Okay, we have to calculate the value of D. Okay, now, so I'm going to calculate the value of D. So D I'm just keeping as it is. Now E is available. So what is E? So the value of E we already selected. Okay. Then I'm going to mod. Okay, mod pi of n. So what is pi? So pi is going to be the pi of n is equal to 20 equal to 1. 20 equal to 1. Okay, I'm just copying this to the next page so that we can continue from here. See, I'm taking like this. Okay, so d into 3 mod 20 equal to 1. Okay, what is this means? This is 20. I want to divide this some number. Okay, I'm going to divide some number divided by 20. My remainder should be 1. The remainder should be 1. Okay, the remainder should be 1. Now, how we can find? How you can find means, now you can see here. Let me take value of d. Value of d, I'm going to take, let it be 0, I'm taking. If I take 0, so d 0 into 3. So everything will become 0. So 0 you cannot take. You can start from 1. You can start from 1. So d equal to 1, I'm going to start. So 1 into, okay, 1 into 3 mod 20 equal to 1. So this is first chance. If I make 2, the value of d equal to 2. If I'm going to take, okay, 2 into 3 mod of 20 equal to, okay, I'm going to check what is that. Okay, let me check. It should come 1. Let me check. Then if I take value 3 into 3, I'm going to take mod 20 equal to, I'm going to take value 4, d value. Okay, if it is 4, okay, what is going to happen? So 4 into 3 mod 20 equal to what? I should get 1, but we'll check. I'm taking value 5. 5 into 3. So I'm just going to try one by one like this. Then 6 into 3. So I'm changing the value of d. So I'm taking 6 into 3 mod of 20. Okay, equal to. Then let me go for 7. 7 into 3. Okay, mod 20 equal to what? Okay, let me stop here. Now, so I'm keep on changing the value of d. 1, 2, 3, 4, 5, 6, 7. I'm changing. Okay, now what is this? 1 into 3. 1 into 3 means it is 3. So 3 mod 3. Okay, 3 mod 20. So if you divide 3 by 20, the remainder is going to be 3 only. Okay, 3 mod 20. So you just take a calculator. 3 divided by 20. If you take, the remainder is going to be 3 only. Okay, you don't have any quotient here. So 3, it is equal to 3. So this is not going to work. That means 1, okay, it could not be your value, d value. So you cannot take 1 as the d value. Then I'm going to take 2. So 2 into 3, 6. So 6 mod 20. 6 mod 20 equal to 6. Equal to 6. So 2 also I cannot take. I cannot take as, okay, the value of d. Then I'm going for 3. 3 into 3 equal to 9. So 9 mod 20. 9 mod 20 equal to 9. Okay, that is the remainder. So now 3 also I cannot choose. Okay, 3 also I cannot choose as d. Then 4. 4 into 3 equal to 12. So 12 mod 20, it is 12. Then 5 into 3, 15. 15 mod 20. 15 is the remainder. Then 18. 18 mod 20. 18 is the remainder. So 3 I cannot choose, 4 I cannot choose, 5 I cannot choose, 6 I cannot choose. Now 7. So 7 into 3 means 21. So 21 mod 20. So what is the remainder here? The remainder is going to be 1. So I'm going to choose 7 as the d value. I'm going to choose. So this is going to work out. Condition becomes true. So 7 I'm going to choose as my d value. Okay. So this is how you have to calculate. So now my d is equal to, the value of d is equal to going to be 7. So this is step number 5. What is the step number 5? Step number 5 is calculate the value of D. So in this case, we selected D. D is our value. So I just remind, we selected P and Q, 11 and 3. This is two prime numbers. Then we calculated N. So N equal to P into Q. Then phi of N, what is phi of N means? P minus 1 into Q minus 1. Yes, that is going to be 20. Then you have to choose a E. E should be in the range of 2 to your pi of N. And GCD of pi of N and E should be 1. We calculated this. So we selected E equal to 3. We selected. Then you have to calculate D. So what is the formula? D into E mod pi of N equal to 1. So here I'm taking the D value I want to find. So I'm checking the D value with different combinations. So finally I come to a conclusion. So the D value is equal to 7. Now almost everything is over. Calculation, okay. The algorithm completely, it is over. Now the next step number 6. What is that means? What is your public key and what is your private key? You have to write your public key and you have to write your private key, public key and private key. So what is the public key? Means you can refer the algorithm. So your public key, KU, public key is equal to E comma N. This is your public key. So your private key is D comma N. This is your private key. So I'm just coming to this example. So in this example, so what is my public key means? My public key is equal to E comma N. This is going to be your public key. So E comma N. So what is the value of E? We already know the value of E. It is 3. Okay, and we know the value of N. N is 33. So 3 comma 33. This is going to be my public key. 3 comma 33. This is my public key. Okay. So what is private key? So the private key is equal to D comma N. Okay. So D comma N is the public key. So what is your public key in this case? We already selected 7. Okay. 7 is your private key. 7 is the D and N is equal to 33. This is going to be your private key. So the private key, you are going to keep it with you, and public key you can distribute to anyone. Okay, public key you can distribute to anyone. Okay, so this is my private key. I keep my private key with me, 7 comma 33. I'm giving my public key 3 comma 33. I'm giving it to you. Okay, now I'm going to send a message. Okay, see here. Now I'm going to do encryption. So encryption, decryption. If you do, algorithm will be completed. Now I'm going for the encryption. Okay, what is the encryption? We already selected our message is 7. Okay, so my message M equal to 7. I'm taking, this is my message. I'm going to encrypt this message and I'm going to give it to you. Okay, I'm going to send it to you. Okay, now what is encryption or how to do encryption? What is the formula for encryption means? You can see the formula for encryption is, okay, C means ciphertext. C is equal to M to the power of E. M to the power of E mod N. This is going to be the formula. Okay, mod N is going to be the formula. So now let me go. Okay, come to our example. So ciphertext, I'm going to calculate. Ciphertext is equal to, what is my message? Okay, I write the formula first. M to the power of E. Okay, M to the power of E. So now, so E should be in the power. M to the power of E. M to the power of E. Okay, now the next one, we have to find, okay, mod of N. So whatever the mod of N, okay, whatever the mod of N, so this is going to be your ciphertext. Okay, let me calculate now. So ciphertext is equal to, so what is my message? My message is 7. Okay, 7 to the power of E. Where is this E available? Okay, where is this E available? Wait. There is something wrong. m of e mod n. Okay. Private key n comma d. Yes. Okay, no problem. It's going on well. Now, okay, no issues. So now, see here. So m is my message. Okay, m is my message. So I'm going to find the ciphertext. Ciphertext C. M is my data. M is my data. Okay, now you can see public key. In the public key, okay, just imagine I'm taking private key is yours. You are having your private key. I'm having your public key. Okay, take like that. Okay, I just go in the reverse. So you are having your private key with you. Okay, the private key is available with you. I'm going to use your public key to encrypt. Now, where is E available? E is available in your public key. So now I'm going to use E. What is the value of E means? The E value is 3. Okay, E value is 3. So now I'm taking 3. So this is power. Okay, I'm taking somebody's public key. I'm doing encryption now. Now, 7 into 3. Then, so this I want to find, okay, mod of n. So what is the value of n means? The value of n is available everywhere. So the value of n is 33. So I'm taking 33. So now, you can see. So 7 is my message. So 3 is available in E. Okay, that is available in the public key. Somebody's public key I'm taking. I'm going to do encryption. Now, so ciphertext C is equal to 7 to the power of 3. Okay, what is 7 to the power of 3? So you can calculate 7 into 7 into 7. Okay, 7 to the power of 3. So you can calculate 7 into 7 into 7. I'm just calculating, I'm doing the calculation in my mobile phone. So 7 into 7 equal to 49. 49 into 7 again, it is going to be 343. So 343, this is the data. 343, sorry, 7 to the power of 3. Now, I'm going to take mod of 33. So this I'm going to divide by 33. So whatever the remainder comes, so mod of 33, whatever the remainder comes, the remainder is going to be the ciphertext. Okay, so 343 divided by mod 3. Okay, I'm having a website. So let me go to that website, okay, to calculate the mod. Okay, I'm just going to this website. I can do it in my mobile phone, but I want you to see. Okay, I want you to see. So I'm going here. So now 343, this is the number. So what is the divisor means? I think it is 33. Yes, 33. Okay, I want to find the mod 33. I'm just going to, okay, send the result. Sorry, 343. Okay, so 343. So divided by 33. Okay, so what is the remainder means? The remainder is 13. You can see. Okay, that is the remainder. So this is going to be your ciphertext. 13 is my ciphertext. 13 is the ciphertext. Now come here. So ciphertext is equal to 13. Now I send the ciphertext to you. Okay, the ciphertext is coming to you. Now you are going to do the encryption now. Okay, I have your public key. You are having your private key. I don't know your private key. So I send the ciphertext to you. Okay, the 13 I'm sending. So you are going to do the decryption now. So I'm going to decrypt. So decryption, I'm going to do it in the other end. So now we received the ciphertext. So ciphertext equal to 13 we received. Now what is algorithm to convert this to the plain text? Now you can see the algorithm here. So what is the algorithm to convert this into plain text means? Okay, so this is the algorithm. Okay, that means the formula. So what is the algorithm means? C. Okay, that means M equal to. So M is the message. That means the plain text. So M is equal to C is the ciphertext to the power of D. Okay, mod N. So this is the formula. Okay, I'm going to apply this formula here. Okay, what is the formula? Message. That means the plain text is equal to C is the ciphertext. We received the ciphertext to the power of D. okay, to the power of d, then mod n. Okay, this is the formula. So c to the power of d. Okay, this is the power of d. So this is the reason I'm using MS Word. Now, so c to the power of d mod n. Okay, so what is the message I want to? I'm the receiver now. Okay, just imagine you are the receiver. You are doing this. You are having your own private key. Now I'm going to calculate m. So m is equal to ciphertext is 13. Ciphertext is 13. Now you have to find the d value of d. So where is this d available? The d is available in the private key. Okay, you can see. So the value of d is available in the private key. That is secret. No one knows this. Your public key, you can give it to anyone. Now I'm going to take, it is 7. 7 is my d. So I'm going to take, so 13 to the power of 7. It should come correctly. Let us see. Now, so 13 to the power of 7. Okay, this is going to be the subscript. So mod n. So what is the value of n? So n value is also available here. So n is going to be 33. So mod n, so that means mod 33. So now I just go, okay, I'm going to make this normal. So this is the formula. Okay, so 13 to the power of 7 mod 33. Now I'm going to calculate. So what is 13 to the power of 7? Okay, I'm just going to the calculator. So in the calculator, I'm going to calculate. So what is the value of 13 power 7? Anybody, please update me in the chat box.
Yes, 7, sir.
How much? I'm not calculating. I'm just tell me.
7.
How much?
The value with the mode is 7.
No, that is okay. But I want to find what is the value of 13 power 7. What is the value of 13 power 7? Calculate. 13, okay, power 7 I want. Okay, if you have the calculator, take the calculator or go for the, what is that? Scientific calculator. Go to the scientific calculator. You can take x to the power of y. Okay, you can use that x power y. So 13. So x power y, I'm giving 3. So not 3, 17. I repeat again. Okay, I repeat again. See. So 13 x power y. Okay, I think you are able to see x power y. So now it is going to be 7. So what is the value means? It's a very big value is coming. Okay, a very big value is coming. So let me note down. So 62748. Okay, you can just click mod. Okay, click here. I just click mod 33. So if I click mod 33, so that is equal to 7. 7 is your plain text. You got the 7. Finished. Okay, 7 is the plain text. Where is that 7? Yes, you can see 7 is our plain text. Okay, so this is the plain text. We encrypted 7 as 13. We send it to the receiver. Using 13, the receiver is now getting 7. Okay, so this is how this algorithm works. Okay, we got the answer. Did you understand? Both the sender and the receiver. Okay, imagine I am a sender and you are the receiver. You must, or we must, you and me should have a key, a same key. Okay, that is called a shared key. We must have a shared key, but without exchanging it. I repeat the words. Okay, please listen carefully. I am the sender. Okay, wait, students are keep on joining. Diffie-Hellman key exchange. Okay, so what is this? What is this algorithm means? Okay, I am the sender. You are the receiver. You are sitting in some place, in a remote place. I'm sitting in a different place. We are connected through the internet. Now, the sender and the receiver, they want a same key, symmetric key they want to share. But they don't want to send it in the internet. I don't want to send it in the internet. If I send it in the internet, I'm creating a key. For example, key equal to 10. I'm creating a key, and this key, I'm sending it to you. Through the internet means any attacker can capture that. So attackers can capture that key and they can use it. So what I want to do means I want to send a key to you, but without sending, okay, without sending in the internet. So both the people, both the sender and the receiver must have the same key. That is a concept of Diffie-Hellman key exchange. Okay, it's something like a magic. Okay, it's something like a magic, some mathematical magic that they are going to do. So by using that, both the sender and the receiver, they are going to have the same key they are going to have. So this is the concept of Diffie-Hellman key exchange. Okay, so what is this? How they are going to do it? Okay, now you can see here directly. I'm going for the algorithm. Okay, so I just included this page. So this is going to be the very clear, a very simple algorithm. Okay, you can see here. So by using this, easily you can understand. Now, here in this case, sender and receiver. There is a sender. Okay, the receiver is available. Alice is the sender. Bob is a receiver. So they are connected through the internet. They want to have a key, the same key they want to have. Okay, a same key they are going to have, symmetric key, but the key should not be exchanged. It should not be exchanged. Now you can see at the end, they are using a key. Okay, K1, K2. K1 is also 9. K2 is also going to be 9. Okay, this 9 should be available in both the parties, for both the senders and receiver, but they are not going to share this 9. They are not going to exchange this 9. Okay, I repeat, Alice and Bob should have K1 and K2. What is K1, K2? K1, K2, both are same, symmetric key. So here, Bob is going to have 9, and also Alice is going to have the K equal to 9, but they are not going to exchange, but they are going to do some calculations they are going to do. Finally, both the parties will have 9, okay, with them. K1 is equal to K2. So they are going to have a shared key here. So that is a concept. Now, how this works, how this algorithm works means, now I'm going to start from here. So the first thing is what they're going to do means both the Alice and Bob, okay, both Alice and Bob, 1 minute. Both Alice and Bob, okay, step number 1. What is the first step? Both Alice and Bob, they are going to accept, okay, they are going to accept 2 prime numbers, they are going to accept. Okay, they are going to agree. They are going to accept for 2 prime numbers. For example, N and G. These are the 2 prime numbers. Okay, they are going to accept. These numbers are going to be public. So there is no problem in that. So they are selecting N equal to 11, G equal to 7. So 2 numbers they are selecting. N and G. Okay, Bob can share this to Alice. Alice can send it to Bob. Okay, no problem. Even if the attacker capture that, so there is no issue for them. So they are going to agree for 2 numbers, 2 different numbers. They are going to agree in the beginning. So that is going to be N and G. Okay. So in this case, I'm going to take N equal to 11 and G equal to 7. This is step number 1. Then step number 2. Step number 2. So what is the second step means? Alice chooses another large random number X. So now Alice is going to select another number X. This X is going to be, okay, a private one. X is going to be a private one. So X, she is not going to share with anyone. So Alice is selecting X, a random number. So the random number X is going to be a private one. So Alice is not going to share with anyone. This is going to be the second step. In the second same here, if you see here, Bob is also going to select a random number. Okay, so that is going to be Y. And this Y is going to be a secret one. And Bob is not going to share with anyone. So already N, G, there are 2 numbers we already selected. This is public. Both they agreed for this prime numbers. Then X is a private number selected by Alice. Y is also a private number selected by Bob. So this X and Y, they are not going to share with anyone, and this is going to be completely secret. Now, let me go to the next step. By using these numbers, that means by using G, N, and X, by using these three numbers, now we have totally three numbers we have with us. So one is going to be N, second one is going to be G, and third one is going to be X. So X is going to be the private one. So using these three numbers, they are going to calculate, they are going to find something called A. Okay, now, so we already know G. So G power X. So G power X means this is going to be 7 power 3. Okay, you can take a calculator and you can do it. Okay, I will show what is the answer later. Now, G power X mod N, this is the formula. Okay, so they are getting some reminder here. The reminder is going to be A. The same thing here they are going to do. Okay, what is that? B equal to, so already G, we already agreed for G. So Y is the secret number, and then mod N also we already agreed. Okay, now Bob is calculating B. So both the sides, okay, they are calculating A and B. Then the next one equal to the next line. What is that? Okay, you see they are calculating here. A equal to value of G is 7 power 3 mod 11. So this is going to be, the answer is going to be 2. Reminder. The same thing. B is equal to 7. G is 7. Y equal to 6. So 7 to the power of 6 mod 11 equal to 4. So here the remainder is 4. Okay, that means B equal to 4. Here A equal to 2. Now they are going to exchange this A and B. A and B will be exchanged. So now A is going to be sent to Bob, and B, the value of B, that means 4, okay, it is going to be sent to the, okay, Alice. They are going to exchange. Now, if the attacker is capturing this A and B, okay, that if the attacker is capturing A and B, attacker cannot do anything with that. Okay, even if the attacker captures this N and G, there is no problem for us because we are using K, that means the X, okay, and Y, this is going to be secret. So without this, the attacker cannot do anything. So now the value of A and B are exchanged. Then the next step we are going. So what is the next step means? Now they are going to calculate the K. This is going to be the secret key. Now what is K? What is the formula for calculating the K? So K1 is equal to, or K equal to B power X mod N. This is the formula. So these two lines is given by this algorithm. Calculating A, calculating K1. This is the formula. This formula is fixed. Now K1 is equal to B to the power of X mod N. So what is the value of B? B is calculated by Bob and it is given here. And here you can see K2 equal to A to the power of Y mod N. So this A is given by Alice. So now I'm taking the value of B. So B is 4. So 4 to the power of X, X is 3. Okay, you can see in the next line, 4 to the power of 3 mod 11. If I take mod 11, okay, 11 is N is the mod 11. So I'm going to get the value 9. The same 9 will come in the next, okay, with Bob also. Now you see K2 equal to, okay, A power Y. So A is calculated by this person. A is 2 to the power of 6 mod 11. This is going to be 9. So both the parties, they are having 9 and 9 with them. So this is going to be the shared key. The shared key is never exchanged here. It is never sent, but it is generated on both the sides. So both are going to have the same key, that is going to be the shared key. So this is called Diffie-Hellman key exchange algorithm. I repeat. Okay, I need another 2 to 3 minutes to repeat. I'm going to repeat it again. So what is the concept of this algorithm? Diffie-Hellman key exchange algorithm. What is the concept? They need to have a shared key, pre-shared key. They must have. Both the sender and the receiver must have a same key. Okay, for example, I take K equal to 9. If I send 9 to this person, somebody will capture that. There are a lot of chances available for data capturing. Your key will be leaked. But what I want to do, I don't want to exchange the key, but both the parties must have the key with them. Okay, they must have the key with them. So what you can do means you can go for the Diffie-Hellman key exchange algorithm. Okay, according to Diffie-Hellman key exchange algorithm, step number 1, what is the first step number means both the sender and the receiver, they have to agree upon 2 large prime numbers, and this prime numbers is going to be public. You can just distribute it to anyone. There is no problem. Even the attacker capture it. There is no issues in that. So here in this case, they are going to select 2 numbers. So one is N and second one is G. Okay, N and G. So N equal to 11 we are selecting here. G equal to 7 we are selecting here. Okay, now Alice is having N and G. Bob is having N and G. So if the attacker captures this N and G also, no issues for us, no problem. Let him capture it. Now, this is step number 1. Step number 2. What is step number 2? Step number 2 is going to be both the parties, both the sender and the receiver, they are going to generate their own keys. Okay, they are going to randomly select some keys. So this is completely, it is going to be private. This is not going to be shared. Okay, so this is X and Y. Okay, now here in this case, I'm taking X equal to 3 and here I'm going to take Y equal to 6. Then using X and Y, they are going to calculate a value called A and B. Same formula. What is the formula? The formula is going to be G. Already we have G with us. G to the power of X mod N. This is the formula. G to the power of X mod N. So this is the formula you have to remember. So G already a random number. We have the value for G. X is the secret key. Mod N. N is also a prime number. We already know this value. So now I'm calculating A. So A equal to 7 to the power of 3. So because the value of G is 7 and X is the private, okay, you can see the colors, different colors. So 7, this is going to be your prime number and 3 is the secret number. So 7 to the power of 3. So 7 to the power of 3 means 7 into 7 into 7. Okay, 3 times 7 into 7 into 7. Then mod 11. So I'm going to divide this by mod 11. Okay, I'm taking the remainder. Remainder is 2. The same thing I'm going to do it in the other end. Okay, so G to the power of Y. Okay, not X. I'm using Y. So Y value is 6 here. So G is 7. 7 to the power of 6. So 7 into 7 into 7 into 7. 6 times. Mod 11. I'm dividing that by 11 and I'm getting the value 4. So this is a remainder. So this is going to be B. Now the value of A and B will be exchanged between the sender and the receiver. I'm going to send the A to Bob. Bob is sending B to Alice. Okay, so the value of A and B are exchanged. Now, so here we received the B. Here we received the A. Now what we are going to do, we are going to calculate the key. So what is the formula for calculating the key means, okay, that means the equation. So K is equal to B to the power of X mod N. Okay, B to the power of X mod N. This is the formula. So B, what is the value of B? So the value of B is 4. So 4 to the power of X, X equal to 3. So 4 to the power of 3. So 4 into 4 into 4, you take mod 11, okay, the answer is going to be 9. So the same answer will come in the other side also. So here, what is the value of A means? So A is 2, so 2 to the power of 6. 2 to the power of 6 mod 11, so this is going to be 9. So both the key, both K and K2, this is going to be the shared key. Now they are going to exchange the data. After this, they are going to exchange the data. All the data will be encrypted by using K. That means K1 or K2. So if Alice is sending, okay, Alice will encrypt all the data by using K. Okay, Bob is going to decrypt it. Then Bob is going to send the data to Alice. So all the data will be encrypted by using K and it will be sent. So this is called Diffie-Hellman key exchange algorithm. So it's a mathematical algorithm. Okay, it's like a magic. Okay, if you calculate any numbers, you can take any numbers, n equal to any two random numbers, prime numbers you take. So randomly you take x and y, apply with this formula, exchange it, and you will get finally K1 and K2 will be same. Okay, so this is called Diffie-Hellman key exchange algorithm.